This is Udemy. If you want to build a website like this, you'll need a database. And in this video, you'll learn how to design that database. I've come up with 13 requirements for this new online course website. Let's check them out and build an entity relationship diagram. The first requirement is where many courses are offered, many students can enroll, and a student can enroll in many courses. Let's open a new diagram in Lucidchart, my preferred diagramming tool. First, we add a table for a course. We also need another table for students, so let's add that now. How are they related? A student can enroll in many courses, and a course can have many students. This is a many-to-many relationship, so we need a joining table. We'll call this one enrollment. We could call it student course, but I think enrollment is a better term to describe what we are storing. We won't always have a good term like this though. We don't know what to store in each of the columns yet, but we know that both the course and student need an ID as a primary key, and the joining table needs foreign keys. Requirement 1 is now met. If you think this video is helpful, then you'll enjoy the bonus I've prepared for it. It's a PDF that contains the final entity relationship diagram, a written explanation of each of these tables and fields, and SQL scripts to create these tables in a database. You can get your copy by visiting databasestar.com/dbdesign. There's a link in the description for this as well. Let's get back to the diagram. Requirement 2 is about the details a student needs to provide, which are an email address and a password. We can achieve this requirement by adding an email address and a password field to the student table. That's a simple change to meet requirement 2. Requirement 3 is about capturing some more information about courses. A name, description, and a price. We can add all three of these as attributes to our course table. It's up to you whether you name the column price or price USD to indicate the currency to make it clearer. Requirement 4 is about how a student enrolls in a course. There's a key point here about payment details not being stored in this system, so perhaps it's handled by Stripe or PayPal or something. In our diagram, we need to capture the fact that a student has enrolled in a course. We already have captured this actually, and it's in the enrollment table. We'll need to add one column to it though, and that is the enrollment date time. This stores when the student has enrolled. There are no tables or columns to record that a course is paid, or credit card numbers or anything like that. Requirement 5 is about modules that belong to a course. Modules have a name and a number. We can create a new table to capture the details of modules. We'll add a primary key and a foreign key to the course table to store the course that the module relates to. We also add a name for the module and a number, which will both be displayed to the students in the course. Requirement 5 is now met. The next requirement is similar, but it's about lessons. They have a name and a number and belong to a module. We can add a new table and call it lesson. We'll give it a primary key and a foreign key so it can be linked to the module table to record which module it belongs to. We'll also add a name and a number for this table, which, like a module, are also shown to students. Requirement 6 is now met. Requirement 7 is about what is shown for a lesson. There is a video and some text which can include lesson information and links. On the diagram, we can add a column to the lesson table to capture the URL of the video. We can assume that there's a feature in the application to either upload a video or link to an existing video. In either case, we don't want to store the actual video file in the database table. We want to store a reference to it, and that's what this column is. Next, we'll add a column to store the text that goes with the lesson. This could be a description of the lesson with links to other pages and resources. It could be a large field to capture data in HTML format. We'll call this column Lesson Details. Requirement 7 is now met. We're over halfway there. Requirement 8 says that a course can be set up so that a student must complete a lesson before proceeding to the next lesson. Some courses will let you move around freely, but for some courses you must proceed in the order of the lessons. On the diagram, we can achieve this by adding some kind of indicator to the course. I'll call it isProgressLimited, and it would store a Boolean value of true or false, or 1 or 0. The application can read this field and put logic into the page to allow or prevent the student from opening lessons. So requirement 8 is now met. Requirement 9 is about quizzes. A course can have quizzes at any point in the course. A quiz has questions with multiple choice answers. How do we define a quiz? We could treat it as a kind of lesson, but a quiz is different to a lesson, so we'll create its own table. We create a table called quiz and give it an ID. How do we relate a quiz to the rest of the database? A quiz can be at any point in the course. We could link it to a lesson, but that means it would have to be shown with that lesson. The same can be said for modules. So we can link it to a course. Let's also add a name and a number for the quiz, as there may be multiple quizzes and we want a way to tell them apart. How do we indicate where in the course outline a quiz should sit? We could use the number field that exists on the lesson and the quiz. However, this would mean that quiz 1 would be shown near lesson 1 when it may not fit there. Or it would mean we have quiz 15, which appears after lesson 14 and then lesson 16 is next, which may not be a good experience. Perhaps we should separate the number of the item from the concept of where it fits. We can do that by adding a new column to both the lesson table and the quiz table. We'll call it course order. We can add numbers into these fields that indicate the order which they should be shown in the course outline. This means that quiz 1 can fit anywhere without having to change the number field. We just change the course order field. What about the rest of the quiz details? Each quiz has many questions, so we'll add a table for that. It has an ID and a foreign key to the quiz table. We also need to add a title of the question, which will contain what the question actually is. Next, we need to capture answers. We add a table called quiz answer with a primary key and a foreign key to the quiz question table. We add a column to record the text of the answer. Finally, we need a way to indicate that this answer is correct or not. There could be multiple correct answers for a question. We can capture this using a field called isCorrect on the quiz answer table. With those changes made, requirement 9 is met. Requirement 10 says that a quiz has a minimum passing score that a student must achieve on the quiz. In our diagram, we can add an attribute to the quiz table called min_pass_score. This would store the score that is needed by a student when they take the quiz. But we haven't got any way to record students that have taken a quiz, so we'll add a table for that. A student can take a quiz many times, and a quiz can be taken by many students. We add a joining table between student and quiz called student quiz attempt. We add the foreign keys from both tables. We can also add the date and time the quiz was attempted, and of course the score that the student achieved. The application can then validate the score the student got against the minimum passing score. Requirement 11 is also about the quiz. A quiz can be set as requiring a pass to proceed. We can achieve this requirement by adding a column to the quiz table. We can call it isPassRequired, which would be a Boolean value, just like the isProgressLimited field on the course table. This requirement is now met. Requirement 12 says that a lesson can be marked as completed, so that a completion percentage can be calculated. To capture this, we need to add a table to record the concept of a student taking and completing a lesson. We'll call it student lesson. We add the foreign keys from both tables. How do we capture the fact that a lesson is completed? We could do this in a few ways. We could insert a record into the table when a lesson is completed, and the presence of a record can be used to calculate the completion percentage. We could use a Boolean column called isCompleted to show either 1 or 0 for each lesson. Or what I think is even better, we use a completed datetime column to show the date and time that the student completed the lesson. I read a suggestion somewhere that it's better to store date times rather than booleans for events, as you can infer that an event has happened based on the date time and the extra information is helpful. Either of these approaches will work though. The last requirement is about capturing when a student completes a course. We can achieve this by adding a completed date time column to the enrolment table. This table is what stores information about a student and a course, not just the course itself. Here is our final diagram. This database should allow us to meet all of the requirements we have. We've got information about courses, modules and lessons to store the content. We've also got quizzes for a course along with their questions and answers. We also store information about a student and their relationships to other tables. Just a reminder, if you think this video is helpful, then you'll enjoy the bonus PDF I've prepared for it. It's a PDF that contains the final entity relationship diagram, a written explanation of each of the tables and fields, and SQL scripts to create these tables in a database. You can get your copy by visiting databasestyle.com/dbdesign. There's a link in the description for this as well. If you want to see another example of designing a database, check out this video here for an example of designing a database for a hotel booking system. If you want to learn more about database design and SQL, visit my website at databasestyle.com. If you like this video, consider subscribing to my channel. Thanks for watching.